Hey friends, welcome back to Science Technology. I am Pavan. So, I would give you a grand welcome to our new video of our channel. So, previously, as you remember, we had created videos on the L293D motor driver shield, the ultrasonic sensor, the Arduino Uno, and many more. Right. So, our today's project is gonna be amazing. So we are going to use different projects which we made recently and make a complete new project. Today we are going to build an obstacle avoiding car using Arduino Uno, the L293D motor driver shield, an ultrasonic sensor and a servo motor. So by our previous video you would already know about the motor driver shield, Arduino and ultrasonic sensor. Today I will even teach you about the servo motor. If you are new to our channel, please check out our previous video as it would be difficult for you to understand if you directly come to this video. So please check it out. I'll give you the link in my description. So let's get started. Right, now we are going to start connecting them. Before that, I am going to teach you and tell you about the parts we are going to use today. Right, first for this project, as a chassis or a holder or the body of the robot or the project, we are going to use a cardboard box. Right, and in this cardboard box I have made a few holes for the connection of the parts. Right, the upper hole right here is for the servo motor and this is for the ultrasonic sensors wires, and I have even made few holes right here for the Arduino Uno's connector pin and the switch here. Right, and I have given a power system right inside the box. Two batteries with the switch which faces outside. Easy to control. Right, now that we have got the chassis, let's check out the parts. So obviously we are gonna need an Arduino Uno and the L293D shield mounted on it, as I shown you before. Right, and then we are going to need a servo motor. It's an SG90 servo micro servo motor. And then we are going to need an ultrasonic sensor with its cables. And finally comes the bow motors, DC motors, which runs the car, the obstacle avoiding car. So this is basically a bow motor with wires soldered. We need 4 of these and 4 wheels for them. Right, now that we have got the parts, let's start wiring. Now we have all our parts ready. Let's start wiring. First, make few holes just like I have did in my box. One for servo motor, one hole for the wires of the ultrasonic sensor, one for the Arduino cable and the switch. Now open the box and it will look some like this. I have connected my batteries right here with a switch and 2 wires open here. Now turn the box and start connecting bow motors with a glue. I am using the hot glue gun to stick it. Now start sticking one by one. Now we have the motor stuck. Now let's start with the other parts. Now make 4 holes each side of the motors and push the wires through it. After you get the wires through, it will look some like this. Now get the Arduino and the motor driver shield into the box. Now we have to connect it respectively. The left two motors wires come out from here, must be connected to pins right here, M3 and M4. And the other two motors in the right, which has wires from here, must be connected to M1 and M2. Now complete the connections. So now we have our program right here. It's quite lengthy but easy to understand. Don't worry, I'll explain it to you. And this time, after you watch this video, when you open the code, you have to understand, right? So I even added comment lines this time, which will explain you everything. Right, now let's start from the beginning. First I have included the libraries needed. This is the new library, servo.h, which you have to download from the include library, manage libraries. These two libraries I had explained in my previous video. Please check it out. And all these were also done, and even this, and also this. Here we have defined the motors, and here the ultrasonic sensor. Then a variable for the servo library, and this is a bit of calculation for the analog connection of the ultrasonic sensor. Our servo motor is attached to pin number 8. As when you saw the PCB board of the L293D motor driver shield, when you go upside down of the shield, you can see the mini connection wires which go through the PCB and connect different pin outs when we mount the Arduino. And the pin where we have connected our servo motors signal or out pin has the connection of wire from the PCB board to the pin number 10, digital pin 10 on our Arduino. So as soon as it starts, as you know, the white setup is going to turn 155 degrees every time when it starts. Then wait, then it is going to read this function, and then wait, and again 4 times. Then void loop. Here distance right and distance left has been set as 0. Then delay for 40 milliseconds. Now if the distance is greater or equal to 15, first the robot or the car is going to stop, then wait for 100 milliseconds, move backward, and again stop, again move. Then the servo motor is going to look right side, and the ultrasonic sensor will check the surrounding, and then again the servo motor turns left side, and the ultrasonic sensor checks the surroundings. These are all the functions which we have called here, which will be defined further. And this is all a bit of calculation. If the distance right is greater or equal to distance L, it is going to turn right and stop. Then turn left, else turn left and stop. Right. This is the function for look right, which I defined here. So first the servo motor will move 50 degrees, then wait for 500 milliseconds, and then distance read ping. This function will call out later, and then wait for 100 milliseconds, and the servo is going to write 115 degrees and return to distance. Then the function for look left, servo is going to write 170 degrees, wait for 500 milliseconds, and distance for read ping, wait for 100 milliseconds, and turn back to 115 degrees. Then return distance and wait for 100 milliseconds. Then it's going to read the ping again, wait for 70 milliseconds, and centimeter equal to 0.cm. This is from the library, this function. And then if the centimeter is equal to 0, centimeter equal to 250. It's going to set it all by itself. This is the read ping function which we have used many times before, and then return it as centimeters. This is for the ultrasonic sensor. Then the move stop one. Move stop, the motors are gonna stop or release. Just a moment, I will drop two lines of code over here. So motor 1 will run, release, and even the motor 2 release, just like all other places. And if you click Ctrl T, it's going to reformat itself automatically. Then move forward, it goes forward. This is a function to move forward, so goes forward. If it's true, motor 1, motor 2, motor 3 and motor 4 are going to move forward and speed will be set. Then backward, then turn right and turn left. Right, this was all about the code. If you have any doubts, you can ask me in the query section of my website, and this program along with more information about this project, you can find it in our website. I'll give you the link in my description. Right, now we just have to select the port and the board and upload the code, and it will be done. Right, now let's upload the code and test it. It's testing time. Now I'll just switch on the car. As you can see, it moved front, and as soon as it detects an object, it turns automatically. For now, I have kept a turning moment of 45 degrees only. But the distance over here and the obstacles around it is many. So it doesn't move anywhere. It just keeps looping there. I have made this demo for our project only. You can change the data and the value of the turns you need from the code, as I have explained it. So friends, that was all for today. We hope you enjoyed the video. If you find our videos informative, please like, share and subscribe our channels. Thank you. Stay tuned. Have a nice day.